Patterns in nature are visible regularities of form focused in the natural world. These patterns occur in different contexts and can sometimes be modeled mathematically. Natural patterns include symmetries, trees, spirals, waves, foams, tessellations, crackles, and stripes. Objects are said to be symmetrical if their pre-image and image have the same size and shape, but are either mirror images of each other or one has been rotated to go in a different direction from the first. Well, there are three basic types of symmetry: reflection symmetry, rotational symmetry, and point symmetry. Mathematics makes our life more orderly and prevents chaos. Certain qualities that are nurtured by mathematics are the power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem-solving ability, and even effective communication skills. So what is the relationship between Fibonacci sequence and golden ratio? This sequence ties directly into the golden ratio because if you take any two successive Fibonacci numbers, the ratio is very close to the golden ratio. As the numbers get higher, the ratio becomes even closer to 1.618. For example, the ratio of 3 to 5 is 1.666. But the ratio of 13 to 21 is 1.625. So, if we are going to relate the Fibonacci series to nature, in trees, for example, the Fibonacci begins in the growth of the trunk, and the spiral outward as the trees gets larger and taller. We also see the golden ratio in their branches, stems into two, and this pattern continues. How can we appreciate mathematics? Okay, so here are a few ways you can recognize and appreciate math and statistics all year long. 1. Appreciate the math that goes into your technology. 2. Consider the math that makes travel possible. And number 3, don't take your education for granted. Mathematical language and symbols in Unit 2. Mathematics is written in a symbolic language that is designed to express mathematical thoughts. The language of mathematics makes it easy to express the kinds of thoughts that mathematicians like to express. It is precise, able to make a very fine distinction. It is concise, able to say things briefly, and it is powerful, able to express complex thoughts with relative ease. Nature of mathematics as a language. Because math is the same all over the world, math can act as a universal language. A phrase or formula has the same meaning regardless of another language that accompanies it. In this way, math helps people learn and communicate even if other communication barriers exist. How mathematics as a language is useful in communicating. The language of mathematics itself is a thinking tool that facilitates mathematical understanding and connects to natural language and everyday thinking. In summary, communicating mathematics orally, in writing, and using symbols in usual representations is vitally important to learning and using mathematics. Arithmetic operations should always be carried out in the following order. First, simplify the expression inside parentheses, brackets, braces, and fraction bar. Second is evaluate the process. Third thing that you need to do is to do all the multiplications and divisions from left to right, and do all the addition and subtraction from left to right. Problem solving and reasoning in Unit 3. There are 8 steps to problem solving. First, define the problem. What exactly is going on? Second, set some goals. Brainstorm possible solutions. Rule out any obvious options and examine the consequences. Identify the best solution, put your solution into practice, and finally, how did it go? Inductive and deductive reasoning. Oftentimes, we encounter seemingly contradictory informations such as nuclear power is good and nuclear power is dangerous. When faced with confident claims from both sides, it's often difficult to arrive at a conclusion as to which opinion is true. Deductive and inductive reasoning are two cognitive processes that we might use to arrive at a certain conclusion. Deduction is the process where a conclusion is drawn based on the acceptance of a number of premises or gradual principles. In other words, we first consider general information before we make specific conclusions. Consider a couple of really general statements such as monkeys likes bananas, or monkeys like bananas, and Lucy is a monkey.
Solving problems using Polya strategy. A polo shirt and a necktie together cost 700. The polo shirt cost 350 more than the necktie. How much does the polo shirt cost? Polya's 4 steps: understand the problem, devise a plan, carry out the plan, and look back. Analysis. Considering that the total payment of a polo shirt and a necktie together is 700, we need to find two amounts whose sum is 700. Since the polo shirt costs 350 more than the necktie, we can deduce that their difference is 350. We let y the cost of the necktie. Y plus 350 equals the cost of the polo shirt. Y plus y plus 350 is equals to 700. It is understood that every variable has a coefficient of 1. So we inverse separated them. So we got y is equals 175 as the cost of the necktie. Consequently, the necktie costs 175 and the polo shirt costs 525. 175 plus 525 is equals to 700, and 525 minus 175 is equals to 350. So, I conclude that my answer is really correct.